In the last video, we looked at the difference between metalness and specular workflows, and I briefly touched on the principled shader as it relates to which maps you need to use with it. In this video, I'd like to go over the rest of the principled shader options, since it's now included in the official version of Blender and it's a bit easier than building a node group manually. So I've already gone ahead and added in our PBR textures to this shader in exactly the same way that we would have plugged them into the shader that we had already built. So the base color texture just goes straight into the base color, the metalness texture goes straight into the metallic, the roughness texture goes into the roughness, and so on. The bump just goes right into the normal right there, after we've combined the two. So let's take a look at the rest of these options. First up under base color is the subsurface, and I have a second principled shader over here on the right just to show this a little bit more clearly. So if I turn the subsurface all the way up, it's essentially going to mix the base color diffuse with a subsurface scattering of 1. So if we turn the specular down to get rid of any glossy component and turn the base color to be the same as the subsurface color, we would get exactly the same result as if we had just used a subsurface scattering node to begin with. So essentially this option here is going to be the exact same as the scale in the subsurface scattering option. So if you set this to 0.5 and set this one to 0.5, they're also going to match. Now the limit here is 1, just because that's basically as high as you'd ever really need to go in a practical case, but if for some reason you need to go higher, you can actually do that. It just doesn't let you slide up that value, but if you manually type it in, then you can go as high as you'd like. So with that, the subsurface radius is the same as it is here at the subsurface scattering node, where it gives you a different scattering radius for the R, G, and B wavelengths, and that's not something that's particularly artist friendly, and I honestly don't ever use it. Especially since we already have the subsurface color option. It's just going to shift the colors around a little bit. So if you need that, it's there. If you need to get really technical, but for the most part, just change the subsurface color. But what's nice about this is that we now have a separate base color for our diffuse, and it's just mixing that in with our subsurface, so we don't need to add a whole bunch of nodes to get the same result. So moving on back over here to our PBR setup, taking one last look at the subsurface, if we turn this all the way up, you can see that we're now getting a much softer version of this. However, it's not affecting the metal areas, because one of the properties of metal, if you remember, is the fact that it's not actually scattering underneath at all. So these two kind of contradict each other, so you're not going to get any scattering in those areas. However, if you were to turn the metalness all the way down, then you'd get scattering everywhere. Now, if you want the colors to remain intact, you can always take the base color and plug that into the subsurface color, and that way you'd get roughly the same colors there. Now moving on down, beneath the metallic option we have the specular, and this is a curious one because if you remember from the last video, we're not using the specular workflow, we're using the metalness workflow, and one of the downsides of the metalness workflow that I talked about is you don't get a very clear way to change the IOR. Now we do have an IOR value here at the very bottom, but this IOR value is only going to affect the transmission, or when it's transparent, and I'll talk about that in a second. But for now, the reflective value is actually going to be inside the specular. So if you've made your own PBR workflow, you might be using the term IOR for non-transparent objects, but in this case it's just called specular and is going to use a different value. So it's intended to make things a little bit more artist friendly. Just know that if you turn this down, you can see that our non-metal areas, let's zoom in here a little bit, we're not getting any of the Fresnel around the outside. However, if we turn this all the way up, then we are going to get that Fresnel effect. And so it's just going to, again, change the IOR value. Usually I'll just eyeball it between 0.25 and 0.5. The examples given in the docs is water, which has an IOR of 1.33, would actually have a specular of 0.25, and glass, which has an IOR of 1.5, would have a specular of 0.5. So if you need to do a conversion, there's a little bit of math involved, but typically just anywhere between 0.2 and 0.6 is pretty good. And again, if you do need to go higher than 1 for some reason, if you're doing diamonds or any really, really dense material, then you can just type that in manually. So I'll leave that at about 0.5. And underneath that, we have the specular tint. Now, the specular for non-metallic objects should not be tinted at all. So this is a strictly non-physically based setting. So as soon as you switch this on, you're going to get results that aren't quite accurate. However, it can be used well for artistic interpretation if you just need a little bit of extra color in there, or if for some reason your material is a very strange one and doesn't have exactly the properties of either a dielectric or metallic. So maybe it's just an in-between. So you can use that specular tint there, but typically I will leave it off. Now under the roughness is the anisotropic, and I'll take out the roughness and metallic just so that we can see this a little bit more clearly. Let's see that highlight. If we turn down the roughness and then turn up the anisotropic, this is essentially the same as switching the glossy shader out for a anisotropic shader. It's going to lengthen those highlights along the tangent of the faces. Maybe turning the metallic all the way up will help us to see it better. I'll take out the normal, and then we can change the anisotropic rotation such that it's now going in different directions. So if I zoom out, hopefully we can see that better. There we go. So the reflection is running in a straight line all the way down the side, and as we change the rotation, we can change the direction of the tangent. Now if you have a custom tangent to manipulate this, you can plug that in here at the bottom. That's pretty much the only use for this that I can think of, and I don't think I would be doing that very often because it's automatically plugging in the face tangent behind the scenes. But if for some reason you needed to adjust the tangent, you could do that here, and that could perhaps give you some cool effects. But moving on from anisotropy, we have the sheen option, and this is an interesting one because it essentially just gives you extra Fresnel. So let me turn down this and plug my roughness back in, and my metallic, and let's zoom in here really close to some of these edges. So by increasing the sheen, we're going to get a little bit of extra glossy at the sides, and this is intended to simulate things like fabric, where if you look at it at an angle, there's lots of tiny fuzzies that have that white color. You can see this on, jeans and bed sheets and things like that, and it's not really practical to simulate all of those tiny little fuzzy details, so we're just going to fake it with a sheen. So if you want to see this really clearly, let's turn this up to 5, and then you'll see that we're getting that exaggerated Fresnel along the edges. Now we can have a sheen tint, and if you set that all the way to 0, it's going to add pure white along the edges, and if you turn this all the way up to 1, it's going to add the base color along the edges. So normally something like anywhere between 0 and 0.5 would be most realistic, but besides cloth, I wouldn't use this too often. Next after that is clear coat, and this is a cool option because it's essentially just adding another layer of glossy on top of what we already have. So let's say that we turn up our roughness a bit. I'll unplug that just so that we can have a more rough surface. So we're getting a nice wide area of reflection there where it's not too sharp. We can also add a secondary set of reflections by turning up the clear coat. And you can see that in the middle of that, we'll get an area of very sharp reflection. So we can either turn that to 0 or turn this up, and this way we can just have 2 roughnesses to play with and layer them on top of each other. And another reason this might be helpful is if you're using a very metallic material, you can add this clear coat, which is non-metallic. So you can have a coat of gloss directly over your metal material, and that would be similar to something like car paint where you have metal underneath and then you have that gloss on top. So if we were to turn this down and then turn the clear coat up, you can see along the edges we're getting that metallic Fresnel as well as the clear gloss Fresnel. So it gives us a interesting effect and it's something to play with. Next up we have the IOR and transmission, and if we change this, again we won't see any difference because the IOR for the non-transparent parts of this is governed by the specular up here. But if we turn the transmission all the way up to 1, then it's going to attempt to make this transparent, but of course we need it to be not metallic in order for it to actually show up as transparent. And if for some reason you're seeing a lot of black in this, then you can go over to the transmission light path bounces and just turn that up somewhere to 5. I think the default for this file was 2 or 1. You can see that we're getting a lot of nasty black edges, so just turn this up a bit. But that's just going to add a little bit of transparency, and if we turn the base color to pure white, you can see we're getting something similar to a glass shader. So I wouldn't typically use this for glass shader in and of itself, but if you happen to have a material where you need only parts of it to be transparent and driven by a texture, this might be a handy way to do so. So underneath that, we just have the regular normal options for plugging in your normal maps and bump maps, and a secondary option for doing that for your clear coat. So you can have a very bumpy underneath and a very smooth glossy top, which might be really interesting for things like wood floors, where you have a really grainy wood, but over top of that you have a nice polished surface. So with that, that's the introduction to the principled BSDF. Again, the whole point of it is to be very self-explanatory and artist-friendly, so there's not a whole lot to it. I would just encourage you to play around with it and try it out on your own projects and see how it goes.